Hi everyone, welcome to Mr. Wagid's math class. Today we'll be talking about transformation again. If you remember, transformation is changing a figure in a coordinate plane, and the umbrella is the transformation, and under the umbrella, the way we can transform a figure. We talked last lesson about translation. This lesson we will be talking about reflection. And reflection is the mirror image, or just like the eagle looking at his reflection in the water, and it looks like a flip. Reflection is your mirror image. So look at the mirror, you see your image. And the closer you get to the mirror, the image will also get closer to the mirror. And if you step away from the mirror, also the image will step away from the mirror. So consider the mirror is the line of reflection when we talk about coordinate plane and reflecting figures in a coordinate plane. The distance to the line of reflection is the same distance away from the line of reflection to transform a figure in a coordinate plane. Keep that in mind, and I know you'll get it. Okay, remember, reflection is a flip. So here's a triangle, and I am going to flip this triangle. Watch how this triangle ABC, the B all the way on the top. Now I'm going to flip it. Watch how the B is on the bottom. So now did the size change? No, it's still the same triangle. Did the shape change? No, it's still the same triangle. Did the orientation change? Yes, it flipped. The B was on the top, now all of a sudden it's on the bottom. Or even if I flip it this way, also the C changed and flipped. So corresponding sides in corresponding angles are congruent. Therefore, reflection proves congruency too. The image and the original are congruent. Reflection is a flip. Reflection is a transformation in which a figure is reflected in a line called a line of reflection. And the line of reflection is the mirror itself. So let's answer those two questions. Is the blue figure a reflection of the red figure? The first one, that means the blue is the image and the red one is the original. Is the blue figure reflection of the red one? Yes, because it flipped. Now the second one, is the blue image reflection of the red figure? Which means the blue is the image and the original is the red. No, it did not flip because the orientation stayed the same. It slid, which is a translation. Now let's move on to the coordinate plane and see how this works. Here's a coordinate plane with what we learned last time, the 4 quadrants and the signs. Reflection is a flip in a line of reflection. So the first time, look at this red dot, which is the original dot. The coordinates are 5 and 4, both positive because they are in the first quadrant. I want you to reflect this in the y-axis. Reflect this in the y-axis, which means the mirror is right on the y. So the new coordinates for the image is -5, +4. What if I asked you to reflect over the x-axis? If you're reflecting over the x-axis, the original one is 5, 4. They both in the first quadrant. If you're reflecting in the x-axis, then you will see the image right under the mirror, which is the x-axis. And it's going to end up in the 4th quadrant where x is positive, y is negative. So the coordinates for the new image is 5, -4. An algebra rule that you will be using, if you reflect the original coordinate x and y into the x-axis, so you're going over the x-axis, then the x stays the same and the y changes its sign. But if you are reflecting the original x and y into the y-axis, so you go in this way, then the x changes its sign and the y stays the same. Now, with transformation, you're going to have a lot of rules. If you remember how the coordinates work, in which quadrant the original is, and where will it land, and what the signs are, you don't need to memorize anything. But if you like to memorize the rules, those are the rules for reflection. And now we'll move on to the whiteboard to practice. Now we're going to reflect this triangle ABC in the y-axis. So the line of reflection is the y-axis, which means if you have a double-sided mirror and you put it on the y, the reflection would be the mirror image. So if A is in the second quadrant, you will see this through the mirror and it would land in the first quadrant. B is in the first quadrant, and the reflection, you will see it in the second quadrant. C is in the fourth quadrant, and the reflection through the mirror, that's on the y-axis, it will land in the third quadrant. So let's see how this works with counting spaces. You have A, B, C, here's the triangle, and you're going to flip this triangle in the y-axis. You're going to take this and you're going to flip it this way. Watch how the A is in the first quadrant, B second quadrant, and C is in the third quadrant. And now those are the coordinates of the image. So the first way is to count spaces, and then we'll see if it works with the rule 2. To count spaces, B is 1, 2, 3, 4, 5. Go away 5. 1, 2, 3, 4, 5. And you will end up here, and that's your B prime. Now A, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to the line of reflection. Now go away 10 from the line of reflection, and this will be your A prime. Now C is 1, 2, 3, 4, 5 to the line of reflection. Now go away 5. 1, 2, 3, 4, 5, and you end up here, and that's your C prime. Now draw your triangle, and that's the image after the reflection. And that is your triangle after the reflection. So let's see what are the coordinates of the image. A prime is 10, 8. B prime is negative 5, 8. And C prime is negative 5, negative 7. So I wrote negative 5, negative 7. Let's see if the rule will lead me to the same coordinates of the image. Reflection in the y-axis, the original x and y, x will change its sign and y will stay the same. So if you reflect over the y stays the same. So think about all these are the x's and these are the y's. Those are the x prime and those are the y prime. So x was negative, became positive, and the y kept its sign. For B, x is positive, B prime, x is negative, and the y kept its sign. For C, x is positive, C prime, x is negative, and the y kept its sign. So x and y, just change the sign of the x and keep the y the way it is. Or just count spaces. That's the reflection in the y-axis. Now we need to reflect this triangle in the x-axis, which means the mirror or the line of reflection is the x-axis. So anything in the first quadrant will land, the image will see it in the fourth quadrant. Anything in the second quadrant, the image will be in the third quadrant. Anything in the fourth quadrant will land in the first quadrant through the image or the mirror. So again, we can count spaces, see where we land, and then we check the rule. C is to the line of reflection, then go away from the line of reflection. So you have 1, 2, 3, 4, 5, 6, 7, go away 7, 1, 2, 3, 4, 5, 6, 7. You end up here, and that's your C prime. B is 8 to the line of reflection. Now go away 8, and you will end up right here. That's your A prime. Sorry, that's B prime. That is the B prime. Now A is 1, 2, 3, 4, 5, 6, 7, 8. Go away 8, and it will end up here, and that's your A prime, which is the reflection in the x-axis. And now you end up in this. And just remember which quadrant it was. Like C was in the fourth, now it ended up in the first, where both X and Y need to be positive. B was in the first quadrant. It ended up in the fourth quadrant where X is positive, Y is negative. And A was in the second quadrant, end up in the third quadrant where X is negative and Y is negative. And that's how I know if my signs are right. So I don't have to memorize anything. Now let's check and see. What are the coordinates for A prime? It's negative 10, negative 8. Negative 10, negative 8. What about B prime? It's 5, negative 8. Positive 5, negative 8 for the Y. And the C prime, 5 and 7 both positive. 5 and 7 both positive. Now let's check the rule and see. When you reflect in the x-axis, X stays the same and the Y changes its sign. Now if I wanted to follow the rules without drawing the triangle and without writing the coordinates of the image, how can I apply the rule? Since the reflection in the x-axis, X stays the same and the Y changes its sign, then A prime, X stays the same, which is negative 10, and the Y changes its sign from 8 to negative 8. And that's the A prime, and that's what we got here, negative 10, negative 8. B prime, keep the X the same, 5, and change the sign of the Y, which is negative 8. C prime, keep the X the same, change the sign of the Y, positive 7. See how you end up the same way. Whether you count spaces or you follow the rule, you'll end up the same way. Okay, now what if I ask you to translate the image 2 units down, which means you're taking this blue triangle and you slided it down 2 units. So everything needs to go down 2 units. Now, let me use a different color. Let's see if this works. I'm using the image, not the original. So B was here, go down 2 units. It's going to end up here, and that's your B double prime. And the coordinates for the B double prime will be 5, negative 10. And the A was here, A prime was here, and go down 2, it becomes A double prime. And the coordinates are negative 10, negative 10. And the C go down 2, 1, 2, you end up here, C double prime, and the coordinates are 5 and 5. So the double prime is this light blue triangle, and that's 2 transformation, reflection over the X, and then translation down 2 units. Now let's see translation down 2 units. A prime was negative 10, negative 8. B prime is 5, negative 8. And C prime is 5 and 7. Translate down 2 units. That means the X is going to stay the same. So I'm going to keep all the X's the same in 5. But the Y is going down 2. That means X stays the same, but the Y need to be minus 2. And since Y is negative 8, you end up with X stays the same, which is negative 10. Negative 8 minus 2 is also negative 10. Is that A double prime? Negative 10, negative 10. Now B 5 and negative 8, X stays the same, which is 5, but the Y negative 8 minus 2, you end up with also 5 and negative 10. Let's see, B is 5, negative 10. 5, negative 10. Now the last one, C, was 5, 7. X stays the same, which is 5. And the Y subtract 2, so 7 minus 2. 5 stays the same, but the Y 7 minus 2 is 5. Now is C double prime 5 and 5? Yes, C double prime is 5 and 5. That's it for today's lesson. Thanks for watching.